Good evening, sir.
Good evening, sir.
Good evening, sir.
Yes. You people are not yet joined. All of you, one, two, three, four, five. Only five people have joined, and today I'm a little bit late. Okay, then. We'll start immediately. Okay. Anybody started with SAFE, at least preliminary, to draw the isolated footing, etc. Or anybody having any doubt about it? Yes, अविनाश शुरू किया कि नहीं?
शुरू किया सर मैंने।
क्या क्या
बिचा-
पहले
वो प्रैक्टिस मैंने किया उस पर।
हो रहा है ना कोई?
हाँ सर, एक एक चीज पूछना था, डिफॉर्मेशन से 25 से नीचे क्यों लेते हैं? वहाँ डिजिट 25 ही क्यों लेते हैं
क्या
सर?
रिफ्लेक्शन
क्या उसके?
अलाउेबल
हाँ।
सेटलमेंट? हाँ, यू आर टॉकिंग अबाउट अलाउेबल सेटलमेंट.
नो, 1 मिनट सर।
25 what?
डिफॉर्मेशन।
It's not deformation, it's a settlement.
ओके
You're
सर,
talking about
सेटलमेंट।
allowable settlement.
यस सर, 25 ही क्यों लेते हैं?
That is as per our codal provision.
ओके सर।
See, the soil below is not a rigid body. Okay, so whenever there is a pressure, some settlement has to be there. So there is a settlement of 5 to 10 mm in the footing, so which we do not observe by our naked eyes. But if you find out with the help of some strain gauges and etc., or if you go in lab and if you see a compressible material pressed by some concentrated load, then it gets settled. So the area around that point will have some settlement, but that settlement is not at all a criteria of failure. So some allowable settlement we are providing, and based on that we are calculating the spring coefficient, that is soil subgrade modulus. Hello,
ओके सर।
are you getting it? See,
यस सर।
see, if you get a spring, any spring, maybe your bike spring, or maybe your spring that you are using for folder. So the folder spring, it is flexible, so it can easily get compressed when a compressive force is applied on it. The same action is considered when you are putting isolated footing on a soil. Okay, so we feel that it is a hard soil, but there is some settlement, and that's why code has given you allowable settlement up to, for isolated footing, up to 25. That's why we are considering 25. You may consider 20 if you want more stringent or more safe structure. You do not want it to allow any settlement. You can go for, but that depends on the condition beneath the uh, that excavated material at the level of footing. So if you are getting hard rock, then hard rock you may consider allowable settlement as 5 or 10 mm.
ओके सर।
Right? Any other
यस सर।
query? See, these are the
नो सर।
queries that will help you understand the mechanism. So it's always good to ask the query. Yes, Samir. Hello. Can you hear me, Samir Verma? Hello. Yes. Am I audible?
यस सर।
Okay. Okay. But other people are not responding. I don't know. Okay. Let us move to our present discussion. So let me present myself first. Okay. So I'm presenting now. The screen is available. All of you, you can see it. Hello.
यस सर।
Yes, sir.
Okay.
Yes.
Okay. Now let us move to our session. So today we'll directly start with combined footing. So double click on your SAP icon and it will get open, and it will take a little bit time. Okay, today it's not taking a time. Okay, then go to file and create new model. Okay, under new model, first you have to go for your particular code that you are going to use. Here we are using IS456. Then design preferences. Okay, then minimum cover. Now again it is for footing, so I am going for 25. No, not 25, it's 50. So 50. Then bottom cover also 50, top cover also 50. Then we are going to use the bars as 12 dia, and rest of the things are okay. Clear? Hello.
Yes, sir.
Okay. Now, last time we have drawn everything from basic, but today we'll take help of this combined footing, and so we'll be going to this combined footing. Click on that combined footing, and now you will get this. You have to provide this data. Now, whenever you are going for combined footing, let me discuss some points about when you will be going for combined footing. Yes, any idea? Hello.
Distance between two foundation is very close when we
Okay.
use
So
combined.
when you are having distance between two columns, a smaller, and then if you go for design of isolated footing, you might come with some interference of the one footing into the another, or they may be close to each other, and that's why the pressure bulb may get disturbed. And then instead of going for two isolated footings, we may go for combined footing. So the footing will be one, and then from one footing there will be two columns. There could be two columns, three columns, anything. So sometimes it may be four columns also. So for four columns, if they are very near to each other, and then we can provide a combined footing. That is first case. Second case is that sometimes you do not get a projected length of the footing. So the edge of the column and edge of your plot boundary is one and same. So you cannot excavate in someone else property. He will not allow, and because of that, your footing might get eccentric loaded, and for that outer footing uh, or outer column is combined with internal column, and we are providing that type of footing. So let us see one diagram for you. I have prepared one diagram. See, this is our criteria. So let's see. I have done a little bit work on it, and you can take a snapshot of this so that it will be available to you, or I may provide you that, or you can create your own also. So what I'm considering, column A is this column B is this right side column. Both columns are having a size of 15 by 15. That means 0.38 by 0.38. Hello, am I audible?
Yes, sir.
Yeah. Then on column A, we are having a total dead load of 400 kilonewton and total live load of 250. So together on column A, we are having 650 kilonewton as working load. Then on column B, we are having say 500 and 300. So together it is having 800. Now, if you design isolated footing, you may see that the distance between the two footings is very less. So we have decided to go for this. And another thing is that the bearing capacity is less. So the soil bearing capacity considered as per our consultant, he is saying that you can consider only 250 kilonewton per square meter. So the low bearing capacity soil is available over there. and that's why you will get a large footing. So isolated footing might get interference with each other, and that's why we are going for this. Now, a basic work is carried out. So total load, you can see total load is 650 plus 800, which is 1450. Now we are adding 10% for self weight of 40, and that's why total load on the footing will come out to be 1595 kilonewton. Now the SBC is low, so the required area of footing will be 1595 divided by 250. You can get it. So it is coming out to be 6.38. So 6.38 square meter area for two columns. So the combined footing is this. Now we are assuming 1.83 as width, and based on that width we are calculating 351. So if you multiply 351 with 183, you will see that the area of footing is more than 6.38. Okay, then subgrade modulus is also calculated over here, so which is nothing but SBC multiplied by factor of safety. You can see here factor of safety, FOS. Okay, factor of safety divided by settlement. Now the settlement, as this is in kilonewton, this is also kilonewton per square meter, so this has to be in meters. So it has been converted as allowable settlement 25 mm. So 250 multiplied by 3 divided by 0.025, which is equal to this whatever maybe. So how much it will come out? Yes, anybody? Yes, how much it is?
30,000.
Yes,
30,000.
30,000.
Yes, sir.
25, let me calculate it. 25, 250 multiplied by 3 divided by 0.025, 30,000. Yes. So it is coming out to be 30,000. 30,000 kilonewton per square meter. Not per cubic meter. So always see that subgrade modulus is 30,000 in kilonewton per square per cubic meter. Okay, so this is the data that we have defined. थोड़ा काम करना पड़ेगा if you want to use safe for combined footing. So this much is the preliminary data that you have to find out, so that your iterations will be less. Otherwise you can consider any dimension and then you can go on rectifying the sizing as per that criteria. But if you work out this, then you will see that the iterations are less. So now you can see over here. So the architectural data is showing that the columns are 1.83 meters center to center distance. Then the edge of the left edge of the footing is at 84 meter. Right edge of the footing is also 84 meter from the right column, and total dimension is 351 by 183. Now this data that you have to provide for this. So what is the left distance in x direction? How much it is? 0.84, right? See here, plan dimensions along x direction, left edge distance. So I'm writing it in meters, so 0.84. Then right edge distance is also 0.84. And in y direction, now what is happening in y direction? Now you can see that from center, you will see that 1.83, half of that. So 1.83, you may consider this as 1.84, so that it will be more easy. So 1.84 divided by 2, so 1.84 divided by 2 will come out to be 92. So in y direction, upward 92, downward 92, right?
Yes, sir.
Yeah. So you can see that here you will provide it as 0.92 in top edge distance. Bottom edge distance will also be 0.92. Okay. Now the load spacing and sizes. Now here you have to see the geometry. Okay. So if you see that along x direction you are having 3.51, and along y direction you are having
1.84.
1.83, because your structure is like this. Uh, Let us see. It might be something like this. See, if your orientation is something like this, then accordingly x direction will be 1.84, and bottom distance will be 0.84, top distance will be 0.84, and the footing will be like this. So it is as per your architectural data. Okay, so right now we are considering this, and that's why here we'll see that 3.51 in so center spacing in x direction is 1.83, and x dimension is 351, y dimension is 184. So you can check it here. Now, load and spacing either in x direction or in y direction. Okay. So right now we are considering it in x direction. So spacing between the two columns is how much it is? 1.83. 1.83. Right? Hello.
Yes, sir.
Yes, sir.
So here it will be 1.83, and the size of the column. So size of the column that we are considering as 380. So I'm considering it in mm. So I will write it as 380. Okay. Clear? This much data. How we will be entering this data? That I think it is clear, because there is nothing new or very difficult. So can we go ahead now about load values? So load 1 and load 2. So you can consider that. So this is your column A. You may consider column 1, column 2. So 400 and 250 is the dead load and live load, and 500 and 300 is the dead load and live load on column number 2 as per our this. So how much is the load over here? In dead load condition, it is 400, and what is the live load? It is 250. Right? Then if mx and my are there, you can provide that. So you have to when we will be going for results from ETAB, we'll see that. But right now we are having only axial force on column A and column B in case of dead load and live load conditions. Here it is 500, that is in column number 2, and live load is 300. So 500 and 300. Then now here you have to provide approximate depth of footing, and that will edit later on. Okay, so let us consider depth of footing a little bit less. So I'm going for 400. So 400 mm is the depth of footing that right now I am considering. And subgrade modulus. What was subgrade modulus that we have calculated as 30,000? 1, 2, 3. Clear? Yes.
Yes, sir.
So click OK, and he will provide you the data. See here, already he has done all the things. So you don't have to mark the footing, mark the column, etc. So that is the how you can use the templates. now here, as this default template has material properties different, we do not know, so we have to go and check it. So let us define that material properties first. So right now, if you right click on this, you will see that some assignments, geometry, loads, and design. You can see here some different things are there which are not, we are not interested in that. So we'll define that. Okay, so go to define, go to material. Under material, first you will go for add new material. Let us consider grade of concrete as M25, or shall I go for M20? Let us go for M25. So the material name, you can say concrete, CONC M25. Okay. But I have to go for capital. I like that capital. So you can say, or simply you can say M25. So the material that you are defining is M25. Then material type is concrete. Okay. Then weight per unit volume for concrete is 25 kilonewton, and modulus of elasticity, again you can calculate and provide, or you can use the formula. So I'm using the formula. So you can see multiplied by FCK. So FCK is 25
25.
and raised to 0.5 and enter. You can see, or you can directly calculate and provide it over there. And then what is FCK? That FCK, now we are going for 25. Clear? So the
Yes, sir.
material has been defined. Similarly, we have to define another material that is for uh,
Rebar.
rebar. So let's say Fe or HYSD, whatever you want to say. And now I want to use Fe 500. So I will go for rebar, and this will be 78.5 approximately, or you can say 75. Then modulus of elasticity for steel is 2 into 10 raised to 5, so 200,000. Okay, then Fy, now Fy will be 500, and this Fu,
455.
no, that is for 415. For this, it is 585. But actually, it is not used. You can provide 500 also, because we are not using this minimum tensile stress in any calculation. Okay. So this way, we have defined material. Similarly, we have to define what we will have to define. No, the material, only material that we have to define. And now you can select and assign support data, soil properties. So the soil property, okay, we will have to define the soil property also. But yeah, he has considered
Load
it.
combination.
Okay, but let me go for that first. If I go for this, soil property is soil, and let me see what is the property that he has considered for soil. So where it is that soil subgrade properties, soil, yeah, see here, so the soil has been already assigned, and that property has been assigned, so you can go ahead straight away. So after that, we will have to see the design preferences also. So yes, design preferences are clear. This is also clear. So it has been assigned. So we'll go for load pattern. Load pattern is also there. Load combination. So in load combination, you will add new load combination. So combination one will consist of dead load and live load with factor equal to 1 and service normal will be highlighted. Then combination, another combination will be combination 2, where you will have dead load equal to 1.5 and live load equal to 1.5. Okay. So, and consider strength. Click OK. Okay, the combinations have also been defined. Then what else is required? You can see the design strips also. So you can check the design strips. So actually already there are design strips. If I go for C, view, then set display options and design strips, design strip objects. This will be show. Actually, it's not showing. That means it is not there. Okay. Let me see. Go to design strips. Draw design strips, and here you can draw a design strip from this point to this point. And if you have that, how much is the width? That we are considering the width as 1.8. So you can go for 9. So 0.9. So the design strip I will go for 0.9, 0.9, 0.9, and 0.9 and 0.9. Then okay, and you can start drawing it from this point to this point. And you can draw another for column B. So B will be in this line. So you can draw it from this point to under one column, and then there will be another under another column. Okay, so now I will uncheck that show width. Okay, you can see that actually there is the strips are already there, but we have drawn now. Okay, hello, are you
Yes,
getting
sir.
it? Yeah.
Yes, sir.
Now you can see the strips are drawn, and okay, now the thing is that you have to run. So run analysis and design. But okay, we'll see that first. Now he will ask you for that. So I will design a combined footing. We'll use that. Okay. So I have saved it. And you can see the maximum over here. And the first thing is that you have to go for display, show deform shape. Under show deform shape, load combination, combination 1, apply and close. And now you can see the though the allowable deflection is up to 25 mm, but we are just getting 9 mm deflection or settlement below the points columns. So you can check it over here. It is something more. So max is 9. So if I go for this, so 8.77, or you can say 9. So it is definitely allowable. So we do not have any problem with settlement. Now let us check the problem with uh, whether the SBC has exceeded or not. So go to that, show reaction forces, and under that soil pressure, then load combination will be combination 1, apply and close. And now you can see here. So if you are getting over here, you are getting 266 or something. And what is our allowable
250.
250. So it is exceeding. So what we can do? Yes, anybody?
Decrease the depth of footing.
No. See, when you are getting allowable soil pressure exceeded, you have to increase the area of footing and not depth of footing. Depth of footing will be increased in case where when it is not it is exceeding the punching shear. Okay, so
Okay,
you
sir.
have to increase the size of footing. Either you have to increase the length of footing, or you have to increase width of footing, or you have to increase both, whatever. But unless and until you increase the area, that SBC will not come lesser than that means the pressure applied from the soil by the soil will not be less than your allowable SBC. Clear? Yes.
Yes, sir.
So now what you can do? Either you can increase this on this side or on this side.
Both sides,
So
sir.
on both sides, let us consider one by one. So I want to increase the size on this side. In isolated footing, what we have done, we have expanded the isolated footing on both sides. But here we'll do some another thing. So you will understand another process also. Let us say I will increase the length of footing only. So width of footing I don't want to increase. So I will increase length of the footing so that it will have a larger area, and I will increase the length of footing on the column which is heavier. I don't want to increase on this side, so entire length will be increased on right side. Are you getting? Hello?
Yes, sir.
See here, we are having a total load as 800 on right side footing and 650 on left side footing. So there is no point in increasing the length on the left side footing. So I will increase on the right side footing. Of course, you can increase whatever you want. Okay, accordingly, your reinforcement will be calculated later on. Okay then. So how we can increase? So the thing is that I want to move this line on right side. So I must have a point. So I will go for draw and draw points. So click on draw points, and now let's say I want to increase by 150 mm. So the dimension is in mm. So I will increase that dimension by 0.15. Okay. So I will have a point on this side and on this side. Clear? Hello.
Yes, sir.
Now I will edit this footing area. So for that, I have to, the first thing that I must go to selection, and then I will select the footing. And after selection, you can see one area and four edges are selected. After that, I will go to edit, and in edit, see this edit areas here.
Expand.
Expand and shrink will expand in both the sides. So that you can see edit design, edit rebar or replicate grid data. Okay, then it must be in edit, move points, lines, areas. So click on this. Mhm. This is not the offset. To expand, edit areas, divide, expand, split areas, modify.
So expand
Hmm.
shrinkage area.
This will expand on both sides. I don't want that. Okay.
Okay,
So
sir.
exactly it is here only. Move point line areas. Align. It's not align also. Edit and grid data. Edit.
Excuse me, sir.
Yes.
Sir, I think you can use the stretching command in means below this selection point. There is below the selection, not there in the left side. In left side.
Here on this.
No,
Actually,
here.
I'm not using this, but you can yes, you can go to that load definition, property definition. So display. It's not that model. No, actually, it has to be there. So edit areas. It has to be somewhere here. Replicate. 1 minute.
Sir, from the icons you can use, sir. From
Yeah.
below that.
Reshape.
Yeah, next.
Yeah. That reshape.
Yes, you reshape. Yes.
Yeah. This is a reshape object. Click on that and okay.
Sir, you can select the slab and means
Yeah,
foundation, and
yeah. I have selected the slab.
then for that corner you can stretch to the required point.
Yeah, that is the process. Like this. Yes, it's a reshape command, not edit. It's a reshape command, but that in edit also you must get that reshape command. Actually, I don't use these pointers. I go by that file menu only. Anyway, this way you have increased. Now again, you have to select this design strip, and again you have to go to reshape, and you have to reshape it. Select. Let me select this design strip. One area and 4 edges are selected. It's not selecting the design strip. Yeah, now it has selected design strip and reshape, and from this point to this point. Okay, now we'll see that again. Okay, now after that, again you will go for that run analysis, and then now we'll straight away go for show reaction forces, soil, subgrid combination 1, apply and close. Now you can see it is 234. Okay.
Yes, sir.
Now, now you must have understood a fact that why I went for only a 0.15, because actually we are having SBC something around 250, and the soil pressure, the due to that on the previous area was coming out just above 50. It was not much. So based on that, you can decide, and you can start with trial and error also. So you can start with 0.1, then again you can increase by 0.1, or immediately you can go for 0.2 or 0.3, and you can find out the total area. Okay, now this allowable soil bearing capacity is or actual soil pressure is less than allowable bearing capacity, so it is okay. So our footing area is sufficient enough. Now we'll see the punching shear. Now you can again, you can see here you are having a punching shear equal to 0.45, and here you are having a punching shear something around 0.59. Now you can go and check. You may go for 0.8 to 0.9. So that means we are having a punching shear well below our allowable ratio, that one. So we may increase this 0.59. We may increase by reducing the depth of footing. Okay. So you can see that the depth of footing, and for depth of footing, what you have to go? You have to go for the define, then slab properties. Under slab, you have to go to modify, and here you can see 400. Now this 400, you may go for 375 and check whether it is okay. Or okay, then similarly step also you have to change. Step is also 400, so that you have to make it 375. Okay, and then you can run analysis and see the punching shear 0.5, 0.66. So still you can go below, but this is enough because 0.66. Now if you go for 350, it might reach something around 0.9, or you may do it and check it. No problem. Let us see that. Okay. So again, we'll go to define slab properties, then modify, and here 375. So we can go for
300.
No, 300 will not be enough. And again here the property is not considered. Okay. So step here also you have to go for 350 and
Properties.
change the property M20.
Okay.
And then display, show punching,
So run.
run analysis. And display, show punching shear. See here. Now it is 0.81, so that is more than enough, because if you still go on reducing, it might cross that 0.9. So for this column, you are getting 0.81 economical, and here you cannot change the depth only for this footing, because the combined footing will have one thickness only. Okay, so finally our size is sufficient. Then it is passing punching shear calculations. Then we'll see assign, clear display of assign, and we'll see the design now. Now you can go and see the slab design. Show slab design. Now under this slab already you have defined the strips. So we are going for layer A. Then right now you can say show top and bottom bars. Then go for none first. Then fill diagram. Then show rebar intensity per unit width. So he will give you how much area of reinforcement is required in 1 meter. Okay, apply and close, and you can see. So you can check it over here. So what is for this footing? You're getting a bottom reinforcement 3331, and here you are getting 1193, and how much here? 332. Okay, and you can check the minimum and maximum over here. So here you will have that if you go and see this. Okay, so how much it is? 331, and how much here? 411, and this much is bottom reinforcement 1193. Okay, so 1193 in 1 meter. So if you are giving say 12 dia bars, so 1193 divided by 113, you need 10.5. So 11 bars you need, and if you go for 11 bars, and that is also in 1 meter divided by 11 bars. So you are getting 12 dia bars at 90 mm. So you may go for 16 dia bar. So let's see that 119, let's say 5 divided by 201. 1195 divided by 201. That is a bar of, so 5.9. So 6 bars. So in 1 meter, if you are providing 6 bars, then you need 150 as a spacing. So 166 is that, but we'll provide 150. So 16 dia bars with 150. So if you go to that, show the slab design, and now we'll consider this typical. So the top reinforcement that we might go for 12 dia, and bottom reinforcement that we are going for 16 dia, right? And the spacing required that we are providing 150, and let us provide here also 150. Okay, and check. Now you can see you don't need any reinforcement at top and bottom. That means whatever reinforcement that you have provided is sufficient. Yes. So this is
Yes,
for
sir.
uh, bars in the X direction. Now for bars in Y direction, again you have to go to display, show strip courses, and then display, show slab design, then click on B, then first click over here none, rebar, and apply and close. Now you can see the reinforcement is required below this and below this, and minimum is required over here. So that is always a case, but for simplicity we are providing the reinforcement on a heavier column. So here we are getting the reinforcement something around 11
1179.
1179, right? So if we are providing 1179, then again
Divided
1179
133.
divided by 201, it will give you 5.8, means 6 bars. So 1000 divided by 6 bars, it will give again 166. So you need 150. And top reinforcement, you can see a top reinforcement you don't need at all. So it is very less top reinforcement that you need. So you can provide 10 dia at 150. So go to display, show slab design, and in layer B, now this. So here I will go for 10 dia, and here 16 dia with 150, and show bottom bar, show top bar, and apply and close. And now you can see you don't need any reinforcement, right? Yes.
Yes, sir.
So this is how you can develop your combined footing. You can design combined footing in safe as per your calculation. The only thing is that again we are coming to the basics, that some initial information or some initial working has to be done with the help of your results, and these dimensions that you have to find out, so that or you may go for trial and error. Without calculation you may go and start, then in first run you will see that your settlement is getting exceeded, or when you check that settlement is not exceeded, then you will see that your soil pressure is getting exceeded. So whatever may be your bearing capacity, it is getting exceeded. So you will have to increase the size of the footing. And finally you will see that punching shear, if you are going for say any lesser depth, so punching shear failure will be there. So first the settlement check, then punch bearing pressure check, and two-way shear check or punching shear check. After satisfactory result of all these three, then you can go and add design strips, and you can go for reinforcement design, and then you can see a slab design for a strip parallel in to x direction, parallel to y direction, and accordingly you can provide the reinforcement. Yes, any query?
Sir, which
Yeah.
reinforcement we will give? Which reinforcement we will give at the bottommost?
At the bottommost, I have not understood. See, if
Means
I draw,
with the
let me show you that concept. See, see, this is your first point of application of concentrated force, and this may be your second. See here, here you are applying effect. Where is the effect? See here, see these are your forces. Okay, these are the forces, and now if you check it, so total force is 650, and then this is 800, So you can say that uh, $800. This is your condition of the foundation, uh, and if you see you're having upward soil pressure, something like this. So I'm not able to draw it, but you can see upward soil pressure is something over here. Or let me draw it with the rectangle. So this is your upward soil pressure. Yes.
Yes, sir.
So this is your condition. So it is something like this. Now this will give you the idea. Yes. See the bottom. If you see your bending moment diagram, you will see that it is this is a cantilever portion. Then it will be something like this. Okay. So that means in this part, there will be a top reinforcement, and in bottom reinforcement, you will see that, and the same you are getting over here. So if you see the strip forces, display strip forces combination 1.5 and layer B. Let me go one by one. So strip forces. You can see that here a bottom reinforcement is required because the bending moment is drawn on uh, on tension side. So the bottom reinforcement is more in this part. So entire this is having a bottom reinforcement, and you don't have any top reinforcement because you don't get bending moment diagram as a hogging moment because the distance between the two columns is a little bit higher side. So are you getting it? See, you can consider this as a continuous overhang beam with inverted supports, or you can mirror this and then you will understand it properly. Let me show you that. Where is that mirror? See, if you see this, a 650 on left side, 800 on the right side, this is, and if you see the bending moment diagram, you will see that a bending moment diagram is something this something like this. So you are not getting any moment at bottom. The same way here, you will see that you are not getting any moment at top, because exactly upward. So footing, combined footing, I will say that combined footing is just a mirror concept of continuous beam on overhang on both sides. So this is your first support, this is your second support, and there is a overhang on right side, there is a overhang on left side. Then you will understand where you have to provide the reinforcement. And similarly, you can get it through the bending moment diagram also. So even if you go for in B, see in B case also you are getting a bending moment diagram at bottom only, because in this case there is this is the point, and overhang on left side upward direction, and overhang on lower direction. So the same thing, you can check it. So
Sir, in both the layers, layer A and layer B is coming in the bottom.
yeah.
In these two, which one will be the uh, bottommost? Means which one will be coming below?
Okay.
Length
So
one, length two.
yeah.
That's right.
See here, when you have defined the strips, you have already considered B layer is up and A layer is bottom. So you have to provide a reinforcement in A layer at bottom and B layer on the top.
Okay, sir.
Actually, that is just a theoretical point. See, basically what happens, even if you provide a B layer below and A layer above, there is only a lever arm distance of that 16 mm, because you are using 16 diabar. If you are using 12 diabar, then there is only a lever arm distance. There will be a difference of 12 mm. So actually, practically, it has no meaning. I don't know why people feel that layer A is supporting layer B. No layer is supporting any other layer. The entire thing along with concrete. That is the mechanism.
Okay, sir.
Yeah. So even see, if you are talking in a theoretical way, I will say that A layer has to be at bottom and B layer has to be on the top of A. But sometimes you forget, and you do the B layer at bottom and A layer at top. Even then, it practically it does not make any sense. Theoretically, if you say that you are getting lever arm lesser by a diameter, because effective depth will be increased. Yes.
Okay, sir.
Yeah. Any other query? Hello.
No, sir.
Okay, then with this, we'll conclude today's session. And next time, I think we'll go for another combined footing with some zigzag shape. So maybe that is with 3 columns, uh, maybe 3 columns, something like this. Uh, let's say you are having this is something like that. Let's say you are having a column, but of course, if you want, otherwise the concept is same. The only thing is that you have to make some changes. Let's say somewhere here. You are having the three columns, and the three columns are at uh, very the distance between the center to center of the columns is very less. Then you will have to provide a footing something like this. So that too you can design in SAP. Manually designing such type of combined footings is very problematic manually, because it is a cumbersome. But in SAP, as it is based on finite element, you can design this type of footing. Or you may say that let's say one footing is over here, and one footing is over here, and let's say another footing. Let's say these are your three columns.
Triangular footing, sir.
Yeah. So it is not a triangular footing. It will be a footing something like this. Don't matter. Yes, got it
Yes,
now.
sir.
So this type of footing. Now this type of footing, if you want to design manually, it is very very cumbersome. Now here this type of footing you can design easily in SAP, and basically SAP is most of the time I use SAP only for design of such type of complicated footings, because here if you go for combined footing for this also, then this footing get disturbed. So you have to provide a footing something like this. Clear?
Clear, sir.
So shall we go for a footing like this, or you can see the concept is same. Uh, you have to find out a rough area of the footing with the help of loading on this footing, and this footing, and then you have to chamfer the sizes, and then you can provide uh, this sort of arrangement in ETAB SAP, and you can analyze, and then based on that you can further revise the shape. ऐसा करेंगे कि नहीं चाहिए?
Next class, sir.
नेक्स्ट नहीं नहीं अभी नहीं कर Okay then. With this, I will try to get a practical situation of that, and practical forces. Here we are just considering some hypothetical forces and hypothetical dimensions, but I will check in my office, and then we'll go ahead with that information, and we'll provide how to design that trapezoidal type of footing. Okay.
Yes, sir.
Yeah.
Yes, sir.
Yeah, but the principles are same. See, basic does not change anywhere. यही चीज will be using. don't worry. Okay, then with this we'll conclude today's session. I think you people might have enjoyed it a little bit.
Yes,
Something
sir.
yeah, but go ahead with practice. N
Okay,
number
sir.
of any type of hypothetical loading you can assume and start and find out what is the depth required, or you can go for very low bearing capacity, something around 150, and you can check what is the depth and what is the size of that footing you need. So that will help you develop your confidence. Okay, then.
एक्सक्यूज मी सर,
Yeah.
सर सेफ सॉफ्टवेयर में हम वो डिटेल ड्राइंग नहीं निकाल सकते कि जैसे आरसीडीसी में मिलता है हमें?
अरे वो नहीं कर
डिटेलिंग
सकते क्या? नहीं
डिटेलिंग का पार्ट तो है सर।
ये
नहीं सर,
है ना,
मतलब
यहाँ पे डिटेलिंग पार्ट है, बट
ओके
सी my focus is on developing the conceptual understanding. यार वो AutoCAD का अगर आपको ये सारा इंफॉर्मेशन मिलता है तो ये you can go ahead and draw the detail in AutoCAD. Why you are asking? ये ऐसा हो गया ना, किसी राजा को अपने पहरेदार की नौकरी पे लगा दिया। अब अरे वो प्राइम मिनिस्टर है तो उसको प्राइम मिनिस्टर का काम करने दो ना यार, बराबर। See, that is what I think. I don't know when you are having AutoCAD with you, when you are having a number of draftsmen in your office, why you are investing the time in getting that in safe?
यस
Instead
सर।
of you can concentrate on understanding the concept, no? See, सेप का ज्यादा फायदा आपको कब होगा? when you will start understanding the finite element analysis. तो उस पर फोकस करो ना, that is what I want to say, right?
यस सर।
Ketan, are you agree with me?
यस सर, यस सर।
जो ऑलरेडी अवेलेबल है और जो आपके सबऑर्डिनेट आपके ऑफिस में काम कर सकते हैं, उस पर हम क्यों कॉन्सेंट्रेट करेंगे? वो ड्राफ्टमैन को इसका डिटेल निकाल के दे दे, आधे घंटे के अंदर मेरे टेबल पे चाहिए, हाँ? और यू वांट टू इन्वेस्ट योर टाइम इन ड्राफ्टिंग, क्या है? सी वी हैव टू थिंक लाइक दैट। अगर बॉस बनना है ना तो बॉस की तरह बिहेव करना सीखना पड़ेगा। ये नहीं कहना कि सर हम तो नहीं है, अरे अभी से वो डेवलप करो आदत। मेरे एक दोस्त है, वो बोलते हैं अगर आपको करोड़पति बनना है ना तो करोड़पति का बिहेवियर, अपने बिहेवियर में सी हाउ ही बिहेव्स, वो अपने डिटेल रूटीन में लाओ, अपने आप करोड़पति बनोगे, ऐसे नहीं बनोगे। I hope you are getting me in a positive way. See, डिजाइन इंजीनियर बनना है ना तो डिजाइन इंजीनियर की तरह सोचना पड़ेगा, वरना आप 10 किताबें पढ़ोगे ना तो भी डिजाइन इंजीनियर नहीं बन पाओगे, क्योंकि आपका एटीट्यूड वो डिजाइन इंजीनियर की तरह सोचने का डेवलप नहीं हो रहा है। आर यू गेटिंग इट? अविनाश, आई थिंक
यस सर।
you might be agree with me.
बिल्कुल सर।
नहीं होता है, सी, और ये आपको कोई सिखाएगा नहीं।
एक्चुअली केतन सर उसका मतलब था, कहने का सेंस था कि डिटेलिंग का नॉलेज उनको हो जाता तो इसीलिए वो पूछे होंगे।
नहीं, वो डिटेलिंग का नॉलेज तो AutoCAD में ही लेंगे ना यार, उसमें वो मेरा यही कहना है।
हाँ,
सेफ
ड्राफ्टमैन
में
तो
क्यों?
रहेगा ही सर ऑफिस में।
नहीं, सेफ में क्यों करना है? केतन, आर यू गेटिंग इट?
यस सर, नो प्रॉब्लम।
नहीं, मेरा क्या, सी, मैं कॉन्सेंट्रेट नहीं कर पाता हूँ क्योंकि मेरा जॉब है आप लोगों को डिजाइन इंजीनियर बनने के लिए जो रिक्वायर्ड चीज है वो आपको बताना। वो तो AutoCAD में कोई भी बताएगा यार आपको।
केतन You contact me, I will provide some material.
नहीं,
Yes, sir.
मटेरियल अगर उनको ऑटोकैड का हम लोग भी प्रोवाइड
नहीं
करेंगे।
सर, ऑटोकैड का मटेरियल नहीं, डिटेलिंग से रिलेटेड मटेरियल है।
अच्छा अच्छा
एक्चुअली
अच्छा।
एक्चुअली मैंने यूडेमी का बैठा हुआ था, तो
Yes.
मैंने मगर 6 मंथ 7 मंथ बिफोर मैंने सब्सक्रिप्शन लिया था, तो उसमें डिटेलिंग का पार्ट है। मैं इनको दे दूंगा वो आईडी अपना, तो वो लॉगिन करके और स्टडी कर लेंगे उससे।
अच्छा अच्छा, आपके पास
हाँ
यूडेमी का वो
हाँ,
सेशन है?
सब्सक्रिप्शन लिया था मैंने, हाँ सेशन में लिया था 6 मंथ 7 मंथ बिफोर सर,
हाँ,
तो मैं
वो
बोला इनको प्रोवाइड करवा दूंगा।
नहीं नहीं नहीं, वो जिनको जिनको चाहिए सबको देना।
एक ही आईडी है सर, मैं सब डाल दूंगा, आइडिया पासवर्ड, वो अपना
हाँ
यूज
नहीं
कर
नहीं,
लेंगे
हाँ ये बात है।
इनको।
वो और वो 1 साल के लिए ही है ना, शायद उनका वो 1 साल के लिए होता है वो
वो
सब्सक्रिप्शन।
लाइफ टाइम सब्सक्रिप्शन है मेरा सर।
अच्छा, लाइफ टाइम है।
हाँ एक्चुअली वो मेरा मेल आईडी से, तो मैं आई थिंक मैं प्रोवाइड इनको डाउनलोड ही करके करवाऊँ।
नहीं नहीं, नहीं नहीं, आपके मेल आईडी पे आप वो सारा
हाँ इनको मैं कर दूंगा।
डाउनलोड करके वो भेज दो ना।
हाँ वही भेज दूंगा इनको मैं।
हाँ, क्योंकि आपका आपका ईमेल आईडी मत शेयर करो किसी को, क्योंकि ईमेल
ठीक
आईडी और पासवर्ड आपने शेयर किया तो मतलब आपने पूरा
है, उसका यूडेमी का पासवर्ड अलग होता है ना, उसका मुझे चेंज करना पड़ेगा। अभी सेम है बट
हाँ
अभी
हाँ,
चेंज कर दूंगा, उनको दे दूंगा मैं।
अच्छा अच्छा, नहीं ठीक है, वो देख लेना।
ठीक है
देखो
सर।
केतन, वो ही इज वेरी एगर टू हेल्प यू, यू कैन गो थ्रू दैट। और अगर वो सेफ में भी देखना है ना, तो मैं आपको बताता हूँ। मैं यहाँ विस्तार से नहीं बताऊंगा, यहाँ पे जाना है डिटेलिंग, डिटेलिंग प्रेफरेंसेस। ये डिटेलिंग प्रेफरेंसेस सब जो जो लगता है वो देना है। यहाँ पे स्लैब का जो प्रेफरेंस है ये देना है, और कुछ नहीं, बस ये यू हैव टू गो थ्रू दिस, और कुछ नहीं। जैसे जैसे आरसीडीसी में द सेम वे यहाँ पर भी है वो डिटेलिंग, व्हाट इज योर ड्राइंग सीट सेटअप, व्हाट इज योर असाइन स्लैब मटेरियल फुटिंग ग्रुप, वो बीम रिइंफोर्समेंट प्रेफरेंसेस क्या है, स्लैब मैट के रिइंफोर्सिंग प्रेफरेंसेस क्या है, या आपको फॉर्मेट प्रॉपर्टी, ड्राइंग के फॉर्मेट प्रॉपर्टीज क्या चाहिए, ये सब देना है और कुछ नहीं। ओके
ओके सर।
या यस, एनीबडी एल्स वांट टू आस्क मी एनीथिंग, बट मुझे डिजाइन कंसेप्ट के बारे में ज्यादा पूछो, वो कुछ भी छोटा मोटा भी पूछो, उसमें मुझे कोई प्रॉब्लम नहीं। कंसेप्ट है, आपको बेंडिंग मोमेंट शियर फोर्स के बारे में कुछ डाउट है, या आपको पंचिंग शियर नहीं समझता है, या आपको वन वे शियर और टू वे शियर में क्या फर्क है नहीं समझता है, या कोडल प्रोविजन में कुछ कोडल प्रोविजन दिए है, जैसे अभी अविनाश ने मुझे पहले पूछा वो 25 cm में क्यों देना है। सो these are the queries related to design. So I will be more happy to discuss these details. आप ये भी पूछ सकते हैं कि सर वो डेवलपमेंट लेंथ की क्या जरूरत है, और जैसे वायर को वायर चिपकाया तो करंट पास होता है, वैसे वो फोर्स क्यों नहीं पास होता, राइट? होना चाहिए ना। जैसे एक वायर को हम जस्ट कनेक्ट करते हैं तो बिजली तो पास होती है ना उसमें से, होती है कि नहीं होती है? यस।
यस सर।
तो वैसे वैसे फोर्स क्यों नहीं पास होता? मैंने बस एक बार को दूसरा बार नजदीक लाके चिपकाया, then why the force is not getting transferred from one bar to another bar? Why it needs lap? So these are the design queries, और ये बेसिक पर लोग काम नहीं करते बहुत सारे, तो हम लोग उस पर काम करेंगे तो we will have definitely edge over others. Okay, with this, we'll conclude today's session, and day after tomorrow, we'll go for that trapezoidal or triangle shaped columns, and we'll
सर डिजाइन ऑफ पाइल फुटिंग।
या इट्स जस्ट लाइक पाइल फुटिंग. पाइल फुटिंग में क्या होता है, पाइल नीचे है और उसके ऊपर कैप होता है, और ये कंबाइंड फुटिंग
हाँ
में
वो
क्या
तो
होता
मुझे
है,
पता है सर.
हाँ, कंबाइंड फुटिंग में कॉलम ऊपर है, उसके नीचे कैप है. बट द सेम प्रिंसिपल यू कैन अप्लाई इन पाइल कैप डिजाइन.
ओके सर.
या सिर्फ वो बॉटम का टॉप होगा और टॉप का बॉटम होगा.
ओके सर.
Yeah. Okay, then with this, we'll conclude today's session and we'll meet day after tomorrow.
ओके
you.
सर. गुड नाइट सर.
Good night.
Okay,
Good night,
sir.
sir.
Thank you, sir.
Okay,
Good night, sir.
good
Thank
night,
you.
good night, good night.